Hi, so we're going to be solving rational equations. To just review the steps with you, we factor each denominator, we identify our non-permissible values, we multiply both sides of the equation by a lowest common denominator, and we solve by isolating the variable on one side of the equation. Now, just to remind you, you can get two kinds of equations, at least at this point. One will be linear, and the other can be quadratic. Okay? And then, of course, with solving equations, you should always check your answers. So let's just look at our example here to review all the steps. We're going to solve x over 4 minus 7 over x equals 3. And we're going to use the lowest common denominator to express each denominator as 1. And if you remember from class, I said that that would eliminate the denominator. Okay, and the lowest common denominator for this equation is 4x. And we are going to proceed by multiplying both sides of the equation by the LCD. Okay, so you can see we have a 4x on the left and a 4x on the right. And also what you can see is that we've identified our non-permissible value as x can't be equal to 0. Okay, so we're going to distribute the 4x over the binomial on the left. So we get 4x times x over 4 minus 4x times 7 over x is equal to, and then just the 4x times 3. Okay, so when we go 4x times x over 4, we can reduce the 4's, and we're left with x times x, which is x squared. On the middle portion, we can reduce the x's, and 4 times 7 is 28, and 4x times 3 is 12x. Because this is a quadratic, okay, and we know that because we have an exponent of 2 on the x, we are going to set everything equal to 0. Okay, so that means moving the 12x over to the left, and it becomes negative. All right, so then we're going to solve by factoring. Okay, and we find that x equals 14 and x equals negative 2. Now, the purpose of your non-permissible value is to let you know whether your solutions are possible. Okay, and because the only value that x can't be is 0, then we know that 14 and negative 2 are possible answers. Okay, or that they are answers. So it is important to realize that non-permissible values are identified from the original equation and that these values cannot be solutions to the final equation. Okay, so let's try our first example. We are going to solve a rational equation, and we are going to determine the non-permissible values. Okay, so remember, your first step is to factor your denominators. So the one on the left, we've got z squared minus 4 in the denominator. That's a difference of squares, so we're going to factor it as z minus 2 times z plus 2 plus 10 over. We have a common factor of 6 in the denominators here, so we're going to take that out. We've left with z plus 2, and that's equal to 1 over z minus 2. All right, and as you can see, you can't factor that one. Okay, so we can do our non-permissible values right now. All right, we've got a z minus 2, which can't be 0, so z can't be 2. We have z plus 2, which can't be 0, so z can't be negative 2. And our LCD, okay, is z minus 2 times z plus 2, and don't forget the 6, okay, because that's part of one of our denominators. All right, so now what we're going to do is we're going to take each part of this equation and we're going to times it by our LCD. Okay, so we're going to go 6 times z minus 2 times z plus 2 times 2 over z minus 2 times z plus 2 plus our LCD again, so 6 times z minus 2 times z plus 2 times 10 over 6 times z plus 2, and that's equal to our LCD again, so 6 times z minus 2 times z plus 2 times 1 over z minus 2. Okay, and so next we're going to reduce what we can. So over on the left here we can reduce the z plus 2 and the z minus 2. And then in the middle we can reduce the z plus 2. And on the far right we can reduce the z minus 2. Okay, so what are we left with? Well, 6 times 2 is 12, plus we've got, oh, look what I forgot to do. I forgot to reduce the 6's. Okay, so now we're going to have 10 times z minus 2, which will give you 10z minus 20, and that's equal to 6 times z plus 2 times 1, which will give us 6z plus 12. All right, notice we have a first degree equation, which means it is linear. Okay, so we don't have to worry about factoring or anything, so we're just going to bring all of our z's over to the left and our constants over to the right. And so we're going to move the 6z over. 10z minus 6z is 4z. On the left we have 12 minus 20, which is negative 8, and we're going to bring the negative 8 over to the right and add it to the 12. So we're going to have a negative 8 turn to a positive 8 once it's on the other side. So we get 12 plus 8 is 20, divide by 4, and we get that z is equal to 5, where z cannot be equal to plus and minus 2. Okay, so notice that our non-permissibles are that z just can't be a positive 2 or negative 2, so 5 is reasonable. Okay, that is a solution, but we're going to check anyway. So let's check over here. Okay, and just a reminder, you want to always check into the original equation, and you want to show that the left side is equal to the right side. Okay, so we're going to go 2 over z squared, so 5 squared, minus 4 plus 10 over 6 times 5 plus 12, which is equal to 1 over 5 minus 2. So now we've got 2 over 25 minus 4, which is 2 over 21, plus 10 over 6 times 5 plus 12, which is 10 over 42, and that's equal to 1 over 5 minus 2, which is 3. Okay, and when we simplify what's on the left, we get 1/3, and that's equal to 1/3, so the left side equals the right side, and so 5 is our answer. Okay, next one. Alright, so now we're going to take a look at an example where we have an extraneous root. Okay, so remember that an extraneous root is a solution, or a root that you get at the very end on the last step that doesn't work in the original equation. Okay, so we're going to go through first and start by factoring our denominators. And we don't have too many of those to worry about, just the one on the right. Okay, so k squared minus 4 is a difference of squares, so we're going to get x plus 2 times x minus 2. Okay, our non-permissible values, we've got k plus 2, can't be 0, so k can't be negative 2, and we have k, oh, that should be k, shouldn't it? Okay, and k minus 2 shouldn't be 0, or can't be 0, so k cannot be equal to 2. All right, and our LCD is going to be k plus 2 times k minus 2. All right, so we're going to multiply every part of our equation by our LCD. All right, so this part, the middle part, and the right part. So we go k plus 2 times k minus 2 times 4k minus 1 over k plus 2 minus k plus 2 times k minus 2 times k plus 1 over k minus 2 equals, and then k plus 2 times k minus 2 times k squared minus 4k plus 24 over k plus 2 times k minus 2. Okay, so let's do some reducing. On the far left, k plus 2's can reduce. In the middle, the k minus 2 can reduce. And on the far right, k plus 2 and k minus 2 can be reduced. Okay, so we now have, on the left, k minus 2 times 4k minus 1 minus, and we're going to put this in a square bracket because we want to minus the whole thing, and we have k plus 2 times k plus 1, and that's equal to k squared minus 4k plus 24. Okay, so we're going to FOIL on the left. We're going to get 4k squared minus 9k plus 2 minus, in brackets, k squared plus 3k plus 2 is equal to k squared minus 4k plus 24. Okay, now note, we have to distribute the negative because we want to minus everything inside the bracket. So we're going to have 4k squared minus 9k plus 2 minus k squared minus 3k minus 2 equals k squared minus 4k plus 24. Okay, so because we have k squares, we know we have a quadratic. And so we want to make everything equal to 0. And when we do that, we will get 2k squared minus 8k minus 24 equals 0. We have a GCF of 2. So we'll factor that out. So we get k squared minus 4k minus 12. And then we can factor our trinomial. The factors of 12 that will give us 4 are 6 and 2. Make the 6 negative, the 2 positive. And we'll go over here. And so we get that k is equal to 6 and k is equal to negative 2. All right, now let's go back to our non-permissible values. Okay, we know that k can't be negative 2 and it can't be 2. And take a look, one of our solutions is that k is negative 2, so we have to reject this one. Okay, and so our answer is k is equal to 6. Okay, so the negative 2 is your extraneous root. Okay, so it's the root that you get that isn't a possible answer, okay, because of your non-permissible values that you have up here. Okay, so I'm going to end this now, and then I'll do a part 2 for the word problems.